All right. So optimizing the. Oh wait. Well. Oh no, wait. No. I got the wrong slides here. Wait, let me just a sec. No. No. Oh, hooks. Yeah. Everybody wants to hear about hooks. We have hooks there. You cannot have a talk at a React conf without hooks. React. Yeah, that's one. Okay. So optimizing the critical rendering path in React, but actually. I was just about to go with this title on stage, and then I sat through the day here in Berlin, and we had a great talk earlier this morning by Monica, where she said that the world is bigger than React, and I actually believe that. I think that we shouldn't necessarily focus on the frameworks, on the libraries, and blah, 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 and all this other stuff. And Kitze also showed us the same thing, right? He had a very inspirational talk earlier about the things we should really focus about. So I'm actually thinking of just naming this optimizing the critical rendering path, because this is about performance. It briefly touches React, because my experience is in optimizing React applications, but whatever I'm presenting here can easily be applied in Angular, in Vue, and pretty much in all the frameworks in any architecture that is coined as a single page application. Actually, I don't like this term. I prefer to use the bloated JavaScript application term, which is a bit more, maybe it's a bit more rewarding as you do performance. So while trying to set the stage, again, my name is Alex, and I'm coming from Cluj. If you want to follow along the slides, I have this link here, bit.ly/optimizecrp. There are a lot of links there, so you don't need to take pictures during the presentation. You can go online, and the slides are already there. And yeah, as Yanni said, I work for Teleport HQ, which is a startup from Cluj, where actually the thing Kitze had in his presentation earlier is what we are actually doing, trying to generate design and code from sketches and from visual editors. I also do JSHeroes, probably one of the biggest non-profit conferences in Europe, which sadly next year is going to be in parallel with React Amsterdam. But in case you want to visit our beautiful city in spring, which is really beautiful, you can find me afterwards. I have discounted links for communities, so I would love to talk to you about the conference. Now, back to our topic for today. We were going to talk about performance, and performance is basically I see it as contained in two dimensions. Like, we have to understand, in order to actually work on performance, you have to understand the context and the process. These are the two main dimensions. So the context would be any external factor that affects your web application, whether it's the internet connection, the mobile or desktop device that the users have, the browsers that they are using. And context is, the bad part about context is that you cannot really affect it in any way, right? The context is there, you just have to work with it. So you have to understand the context in order to know what and when to optimize. So context might be good if you're living in certain parts of the world where you have a good internet connection, you have a cheap internet connection, you have access to modern devices, but context can also be bad in a lot of places. So you have to definitely understand the context before you actually proceed with anything in doing performance optimization. And the second part is the process. Now, the process here is trickier because this is where it gets technical, right? You have to understand how does a web application work? How does it end up in the browser, right? What does the browser do from when you access the URL, which is point A, all the way to when you have a rendered application on the screen? And the problem is that we usually see performance, or we usually see the browsers as being fast, right? This is a common misconception about web performance, that browsers are fast, because again, we are not necessarily thinking about the context. And we also see the browsers like this, okay, I want to get from point A to point B, so it's like this multi-lane highway, right, that just ships resources across a very fast road. But actually, the better metaphor for how the browsers work is more like a busy city with a lot of street lights. And at times, those street lights might be red. So the browser wants to go from A to B. It goes to one point and it hits a street light. And it's red. So when it's red, the browser has to stop. If it's green, the browser can continue. Now, this kind of like understanding context and performance, understanding context and process is important because you get into what I like to call the performance mindset. Now that you're basically looking at, okay, this is the root of the problem, now you can actually start working on things. You can actually look it up. Okay, what does it mean? What can I do to help the browser, right? What can I do to help the browser get only through green lights as it moves from A to B? And the problem here is that when you start looking into performance, it gets really technical, and you get these terms like critical rendering path, like first meaningful paint, like speed index, right? Who knows what speed index is? It's a very interesting metric, but it has a lot of, when you read the description, it's like, what? And then you say, okay, no, actually, no, I don't want to do this. Let others deal with performance because I'm just going to build for fast MacBooks working on Wi-Fi's. Now, let's try to demystify this. Let's try to understand exactly what it means what these terms mean and what are we looking at when we talk about web performance. So this video shows how the Twitter mobile web application, so this is a browser, it's just a progressive web app, but it's still like the browser version of the mobile app. So this shows how the app loads on a 3G connection. So you see there are multiple steps that you can identify here. A loading indicator, some content at the top, now some relevant content in the middle, images appearing a bit later. So if we were to unpack this, we have certain steps, right? First time you have a blank screen, right? Then you have what is called the first paint, when the browser first paints a pixel that is relevant, that is part of your application. So this is the first time that the user actually sees something. Oh, I'm actually supposed to get something. I won't just stay here indefinitely. Then we have the first contentful paint, when the browser actually paints some text node or something that is considered to be content and not just images or loading indicators or stuff like that. And then you have the first meaningful paint, which is the point, this one is very important because it's the point when the user perceives the application as almost being loaded, or at times even loaded, depending on how you do the strategy here. Of course, what is meaningful for one user might not be meaningful for the other one, but most of the times in an application, I'm pretty sure that you can find out what's the meaningful part of the application and prioritize that as you load it. So the first meaningful paint would be, for example, for Twitter, when the user can actually see the first tweet in the feed. Then we have another important event, which is the page interactive, because when we have the first meaningful paint, we might not have interactivity. The scroll might not work, inputs or elements might not be focusable or clickable. But page interactive is the event that is happening as soon as JavaScript is being executed and parsed, and we can actually interact at 60 frames per second with the application. And finally, we have the page loaded when everything else is in place. Now, let's try to take these and put them in another diagram of what happens when the browser and the server communicate, and how we prioritize the resources here. So you get, again, the same objective, getting from point A to point B. You request a page, you get the HTML back. This instant here is called the time to first byte. Then this is the server performance. This is something that you cannot really optimize on the client. Then, as the browser starts parsing the HTML, it finds resources, right? Usually in the head. These resources are called critical resources because whenever the browser finds such a resource, it will stop the execution. It's like hitting that red light. So when the browser finds fonts or CSS or other external resources in the head, it will stop the execution. It will fetch back, the resources will be fetched back, and during this time, the browser will not continue. So the DOM will not be constructed until all the resources are being fetched. Now the DOM is being constructed, the first paint is there, the first contentful paint, and the first meaningful paint, one after another, depending on how many resources are there and how are they prioritized. Then we have to fetch the other ones, like, for example, scripts, or do AJAX calls, or do any other requests to the server. It's very important to try to limit, of course, the amount of resources that we are fetching here. So the critical rendering path is about having the minimal amount of resources in this specific area. Once we hit the first meaningful paint, we can actually continue with the rest of the resources. So we are going to focus on this part here. This part is related to interactivity, related to how you execute JavaScript and how much JavaScript you send to the user. But the goal for today is to simply focus on how can we get that first meaningful paint as soon as possible to our users. And that's the point, right? When we get that, when we optimize that we end up with streetlights that are more green, right? As the browser goes from A to B, it will hit green light and green light and green light. So, of course, the only option to optimize the critical rendering path is to remove elements from the critical rendering path. I hope I won't say critical rendering path too many times because it's already like somewhere here. Okay, so the first thing is to work on experience, right? Remember the bloated JavaScript applications, right? How would they look like on a 3G connection? Like this, right? Waiting and waiting. You actually don't, you have no idea now if this is a GIF or it's actually will display something at some point. It might be 20 seconds until we see something, it might be 30 seconds. What we want is this kind of experience, where we progressively show things. We want an experience similar with what you saw on the Twitter website. So how do we do that? Because the problem with bloated JavaScript applications is that they rely on JavaScript for everything, routing, rendering, pretty much any logic that has to be done. Well, what we can do is switch to server-side rendering. And luckily, modern frameworks, and React in this case, allows us to do that. Using this function called render to string, you can add this functionality in any Express application. So you'll be running a Node backend, and you'll be using React to render your HTML, to render your entire page or part of your page that is meaningful to the user on the server, and then you can ship that page. Now, this will increase the time to first byte because you need to do some more computation on the server, but it will drastically reduce the first meaningful paint time, because now we can actually kick out JavaScript from the critical rendering path. There's an article here linked in the slides on Medium that I wrote about implementing server-side rendering step by step. So if you're interested more in the techniques, you can read that up later. So let's defer JavaScript, right? When we got rid of JavaScript, so when we don't need JavaScript on the client anymore, when we can just use the server-side rendering, we can use something like script defer. With script defer or with script async, but usually deferred is preferred. With defer, you actually move the JavaScript execution at the end of the DOM parsing. So HTML, even if the HTML parsing encounters a script, if that script is deferred, it will not stop the DOM parsing at that point. It will simply download the script on a parallel thread, and then it will defer the script execution after the DOM and the CSS are constructed and put together, and after you have your first paint on the screen. So this is a huge performance improvement in terms of getting the first meaningful paint faster. Let's talk about fonts now. You cannot really show something without fonts, right? And the problem with fonts is that we most likely rely on web fonts, and web fonts need to be fetched like any other resource, so they are a critical resource in this case. The problem is that most of the times you will get a page that has the HTML loaded, that has the CSS fetched, so the page is able to construct the DOM, construct the CSS, put them together, and then as soon as you want to render it, no, wait, you don't have the fonts yet. Okay, we have to wait for the web font to load. Luckily, we have while we wait for the font to load, we have what is called the flash of invisible text. So the page is there, literally all the content is there, but you simply see nothing because the text and the content cannot be properly rendered. In order to fix this, we have font display. There are a couple of options that you can use with font display, and you can actually read on CSS Tricks more about each option and how it affects the website. But for example, an easy solution is to use font display swap, which will simply use a system font while the web font is still being loaded. So you will get a bit of you will get a flash of unstyled text, it's called, but it's still much better than the flash of invisible text, which simply blocks the content for the user. Okay, now we move to prioritizing things. We removed resources from the critical rendering path. Let's try to prioritize and remove even more. One thing which you can do is especially for mobile designs. You know, when you have an app that is loaded on mobile, it's usually very long string of content, right? Because the design gets to be very the design squeezes on multiple rows below. The problem is that the user doesn't need to have everything rendered in the browser. The user only sees this part here. So this is called the fold, the imaginary line at the end of the viewport. So in theory, you could prioritize resources which are above the fold and only fetch those in your critical rendering path. One technique is to inline critical CSS. There are tools for that are scanning your web application, and they are saying, okay, these CSS rules actually apply above the fold. So you can take them out, you can extract them into a separate CSS, you can inline them into the HTML if you want, and you will get one less resource in the rendering path. Also, you can lazy load images. We will talk about images in a bit. And why not? You can progressively load content. We had libraries for that even before React Suspense, but now with React Suspense we can do even more. A couple of libraries that you can also look into. One is Critical by Adi Osmani. It's a library that does exactly that, extracts the critical CSS from your application. And one is React Loadable, which does or used to do what now Suspense will do in the end. We can actually load, can create separate chunks and dynamically load parts of your application only as the user starts scrolling and starts needing those parts. Okay, images. The problem with images is that they are really useful because you want users to have the visual, they want them to feel the visual impact of images, but most of the times we are shipping full HD images on 360 pixel screens for mobile. Very few websites implement responsive images. So one of the first thing you have to take into consideration is, can I load images based on the resolution? And yes, you can. Using the image source set attribute, you can actually specify different image sources for different media queries. You can, again, lazy load images. So for example, all the images which are not in the viewport, whether they are a carousel, maybe you have a carousel of 20 items for whatever reason, you should not load all the 20 images while the app is being loaded, so you're blocking the first meaningful paint. So you can use some lazy load techniques for that. And you can also use modern encodings. The problem with modern encodings is that although they cut in half the size of images, they are not well supported cross browsers. So like Chrome supports WebP and Firefox supports Moz JPEG, but you have the picture element which you can use, which allows you to specify different sources for your images. It's similar to the video element. So with the picture element, you can actually specify multiple sources and the browser will just take whatever it can support. Lazy Sizes is also a great library for image optimizations. It actually has all of these use cases and it's really wonderful. And Images Guide is a great ebook on all these image optimization techniques. Okay, we move on to resource hints, which allow you to play with the priorities even more. So you might know that, okay, I have this font that I know for sure that I'm going to use, but the font is only referenced somewhere in the CSS. So I don't want for the browser to wait for the CSS to be loaded, and only then to be parsed, and only then for the font to actually be loaded. You can specify here in the link rel preload, which allows you to preload resources, and the browser somehow trusts you that, okay, the browser will have to use those resources later. You can also do media queries if you want. The nice part about this is there's a new spec coming in that allows you to write something like this. For any script or any external resource or even a fetch call, so the fetch API will also have this, you will be able to specify that it's an async script and that importance here, which is really interesting. So you'll be able to programmatically set priorities on your resources based on your needs. All of these are affecting this column in the dev tools, right? In Chrome dev tools, you can toggle on the priority column and you can actually see how the browser assigns priorities to the resources. So if you see that the browser assigns a low priority to a certain script that you might need or to an image, you can use preload and it will get more priority. Okay, this is my favorite one, third parties. Don't use third parties if possible. We had a very nasty experience at my previous company where we optimized an application with React from 12 seconds down to 8 seconds, first meaningful paint on 3G networks. And then they decided to add Zendesk for customer support. And Zendesk doesn't minify their scripts in production. And Zendesk introduces, if you're not deferring properly the third parties, we got from 6 seconds to 18 seconds. Perfect. Another fun story about third parties came out earlier this year in May. Do you remember the GDPR madness? So USA Today decided that they're too lazy to implement GDPR rules. So they simply removed all their tracking and scripts and their third parties from the website. And what it turned out was that for European users, the website's total size was down from 5.2 megabytes to 500 kilobytes. So I'm not even sure if we're supposed to thank the EU lawmakers for making the web faster, but anyway, it's an interesting idea, and it's interesting to see how much third parties can actually affect the performance of your websites. Okay, one final note on HTTP2. I have a huge light here in front of me, so I'm not going to ask you to raise your hands. But usually when I ask this, people say that they don't use HTTP2 yet, which always amazes me because it's incredibly easy to switch to HTTP2. And I think it's probably the biggest win of performance that you can actually do with the simplest amount of energy. HTTP2 compared to 1, it works, it's supported, you don't have pretty much anything to worry about unless you don't want to do things on HTTPS, which I hope it's not the case. HTTP2 allows you to pretty much download resources in parallel, which is super useful. You don't have to do any more domain sharding and all those ugly hacks we had to do on HTTP1 in order to get more resources to be transferred in parallel to the browser. Okay, let's move on to tools, because everyone always asks me, okay, what tools should I use to, I don't know, check performance, to run maintenance on performance metrics and so on. Well, Lighthouse is one of them. Lighthouse is a great tool for, from Google, which is integrated into the DevTools. So under the audit tab, you have Lighthouse integrated. Not only performance, but they also do audits on security, on accessibility, on SEO, and all sorts of things. And it'll give you enough metrics that you have at least a few good sprints of performance optimizations for the website. GTmetrix is another great platform that allows you to simply test a website that is online. It will give you a lot of interesting metrics. You're able to see the waterfall charts of how the resources are being fetched and so on and so forth. webpagetest is another one. This is actually also behind Lighthouse. So this is one of the core services of performance, and there are a lot of other tools built on top of it, but you can also use it as a service yourself and see different performance metrics while you're working on websites. And if you need to go into like a more enterprise-y approach, there's Speed Curve and Caliber app, which allow you to do monitoring also and give you daily reports and stuff like that, but you have to pay for the services. Okay, a quick recap. We talked today about performance optimizations, right? Server rendering applications, prioritizing above the fold content, deferring JavaScript execution, optimizing images, using resource hints so you can actually manually prioritize resources, and updating your stack to HTTP2. A few additional resources, which I'm not going to spell because it will sound funny, just links that you can also follow later. A lot of interesting things on performance budgets, on how to measure quality performance metrics, and so on and so forth. That being said, I hope that it's not too late for you to still get a bit enthusiastic about performance. At least I know I am. Maybe you won't be from the first day as enthusiastic as these little guys, but working on performance is actually quite rewarding. And if you get to that point where you understand that this is actually a core user need that you need to address, you will get to that point where you will turn it from the not my job thing, where I don't want to touch performance, to the I actually want to volunteer, actually want to do performance audits, I actually want to see what the hell we are building, how do users under 3G connections experience our website. I hope this is something that you will do the next day at work, maybe not the next day because it's not a good, maybe not Saturday, but still, I hope this is something as a takeaway for you. Thank you.